Hey everyone, and welcome. Today, we're taking a deep dive into one of the most incredible tools for makers and inventors out there, the Arduino Uno. If you've ever looked at this little blue board and thought, whoa, where do I even start? Well, you're in exactly the right place. Let's jump in.
So let me ask you this. Have you ever had one of those lightning bolt ideas for a gadget, an interactive piece of art or maybe some smart device for your home, but the electronics part of it just felt impossible?
Well, that's exactly where the Arduino Uno comes in. It's literally designed to be your starting point. But yeah, I get it. You look at it for the first time, you see all those chips and pins and little components. It can look pretty intimidating, but trust me, we're about to break it all down.
So what even is an Arduino? At its core, it's an open-source electronics platform. Open source just means the design is totally public, so there's a huge community building things with it. And platform means it's a foundation for, well, almost anything you can imagine. The absolute easiest way to think about it, it's a tiny, programmable computer that you can tell how to sense and control things in the real world.
Okay, first things first. Before our little computer can do anything at all, it needs power. It needs energy. So our very first stop on this tour is the power system. This is what breathes life into the whole board.
Right. If we're going to call the main chip the brain, then the power system is, without a doubt, the heart. Its only job is to take electricity from a source and then carefully pump it around the board so every single component gets the exact, stable voltage it needs to work properly.
And you've basically got two main ways to power this thing up. On one hand, you can just plug a USB cable from the board into your computer. That gives it a nice, clean 5 volts, and it's perfect for when you're writing and uploading code. On the other hand, for a project that needs to run all on its own, you can use an external power adapter, like a wall wart, that plugs into this round barrel jack. That can handle anything from 7 to 12 volts.
Now, what makes this system so smart and safe? Well, there are a few key players. You've got these little chips called voltage regulators. They're amazing. They take whatever you give the board and they convert it down to a rock-solid 5 volts and 3.3 volts that the sensitive electronics need. And then there's this little hero, a protection diode. It's like a bouncer at a club, making sure that if you accidentally plug in a power supply backwards, it doesn't get in and fry the whole system.
All right, so the heart is pumping, power's flowing, which means it's time to meet the star of the show. Let's talk about the brain of the whole operation, the ATmega 328P microcontroller.
See this long black chip right in the middle? That is it. That's the ATmega 328P. This is where all the magic really happens. It's a tiny but complete computer. It's where the code you write on your PC gets stored, and it's what reads that code, line by line, to control everything else connected to the board.
But for a computer brain to run through instructions in a consistent, orderly way, it needs to keep time. It needs a steady, rhythmic pulse. You could almost think of it like a heartbeat.
And the speed of that heartbeat, a whopping 16 million beats per second. Yeah, that incredible pulse comes from this tiny, shiny silver component called a 16 megahertz crystal oscillator. It physically vibrates 16 million times every single second, giving the brain that perfect timing it needs to run your code flawlessly.
And hey, what if your code gets stuck? Or you just want to see your project run again from the very beginning? That's what this tiny little button is for. Just give it a press, and it tells the brain to stop what it's doing and restart your program right from line 1. Super handy.
Okay, so we have a brain. It's powered up and it's ready to go. But how do we actually give it instructions? How does the code on our computer make the leap over to that chip? That brings us to the communication system.
The journey is actually super simple. You write some code on your computer, you connect the Arduino with that USB cable, you click upload. But there's a hidden, crucial step right in the middle. See, your computer speaks the language of USB, but the Arduino's brain speaks a different language called serial. This other little chip on the board acts as a universal translator, converting the signals back and forth so they can understand each other. It's the bridge that lets your code get to the brain.
Okay, the board has power, the brain has its instructions. Now we get to the most exciting part of all. How does the Arduino actually do stuff? How does it interact with the world around it? Let's talk about its senses and its voice.
The answer is in these rows of black sockets that line the edges of the board. These are the pins, and they come in two main flavors. We've got the digital pins. Think of these like a simple light switch. They only care about two things, on or off. Perfect for, say, turning on a light or checking if a button has been pushed. Then you have the analog pins. These are more like a dimmer switch. They can read a whole range of values, which is exactly what you need for measuring things that change, like the brightness in a room or how far you've turned a knob.
So what kind of things can you actually connect to these pins? Honestly, pretty much anything you can dream of. LEDs to make things light up, buttons to get input from a user, all kinds of sensors to measure light, temperature, or motion. You can control motors and servos to make things move, buzzers and speakers to create sound. The list just goes on and on. The pins are your gateway to the physical world. This is where your creativity really gets to shine.
And there you have it. That's our tour. From the moment power comes in, to the brain thinking, to the pins actually interacting with the world. We've seen how all these different systems come together to make one incredibly powerful and flexible platform.
So let's just quickly recap the board's anatomy. We've got the power system, which is the heart, giving energy to everything. We have the brain, the microcontroller, which is the boss that runs your code. We have the communication bridge, which is the translator that lets you talk to the brain. And finally, we have the I/O pins, the senses and the voice that let your project actually interact with the real world.